Algebra section A. So we're told to show our working. We want this to the nearest 1,000 and we want registered for the first time Q3 2014. So for 1AI we know about 2014. So 2014 on our data sheet we have the information for 2015 and that it's just over this number of vehicles. So we also know that it is up by 8% compared with last year. So this means that 2015 is 2014 at 100%, 2015 at 108%. We know that 2015 is 876,000, and so from that we can divide 876,000 by 1.08 because it was 108%, and that will give us a calculator value of 876,123 divided by 1.8 is 8.1 8 lots of ones, and we want this to the nearest 1,000. So we're at 811,000. Okay, we are then asked about the third quarter of 2002. So 2002, really similar thing. Our oldest value is going to be 100%, and we know that we are now down by 2%, so that will be at 98% in 2015, and we know that this is 2015 value. So AII is going to be 876,000 divided by 0.98. So 0.98, we'll expect it to be bigger because it was at a peak then. So we are at 894,000. Okay, right. Then we are at calculate how many cars were in 2015. So looking down at the picture bit on our data sheet, we can see that cars made up 81.3%. So for part B, we have our number of vehicles, which is 876,000, and then we are going to times that by 0.813, and that's basically the same as timesing by 81.3 and dividing by 100, so it's just a slightly quicker way of doing a percentage. So times by 0.813, and we have 712,000 cars. So hence basically just means use what you've done. So use what you've done to find the percentage of registered cars. So percentage registered cars, first registered, third quarter. So we're going to need to know the whole number of the registered cars, which is this one. And then from there we can, that's still visible. Yeah, that's fine. So BII, we want percentage of registered cars first time. So our first time we did in the previous question, and that was 712,000, and that is out of from our data sheet, and that's million. So 1, 2, 3, 1, 2, 3, and if we cancel that down, we've got that divided by 302, 1, 2, 3, 4, 5, and then times it by 100 to turn it into a percentage. So we should be looking at about times by 100, and that equals 2.36%. Question 2. Complete and draw the histogram on the axes opposite. So we've got 2a is going to be using this table. So the distance between minus 0.5 and 20.5 is 21. However, this distance here is only 20. This one again is 20, this one's 40, and this one's 60. So we're looking at our class width. Our frequency density, we do our frequency divided by our class width. So 13 divided by 20, 13 divided by 20, which gives us 0.65. 10 divided by 20 will be a half. 31 divided by 40 is 0.775, and then we've got 9 divided by 60, which gives us 3 over 20, or 0.15. We now have to do the histogram. So what we've got is we've got starting at 0 and up to and including 20. We've then got 20 to 40, 40 to 60, 60 to 100, and 100 up to 160. So what you'll notice is these bars are not going to all be the same width. So for our first one, we'll take it up to 0.81. Second one will be up to 0.65, and what you should end up with is a graph that looks like this. So it's got slight positive skew, we are then asked to calculate an estimate for the mean and the standard deviation in these 80 frames. So to do mean, we are going to need to use the midpoint times by the frequency. So we'll have 30 times by frequency is 13. This first one would have been, actually if we start at the beginning, it's more sensible. So we've got 10 times 17, we've got 30 times by 13, we've got 50 times by 10, we've got 60, no, we've got 80 times by 31, and we've got 130 as our midpoint times by 9. So that's fine if you're going to do it longhand. If you're going to do it on a calculator, then this will go in list 1, this will go in list 2. Make sure your settings are for one variable, looking at frequency in list 2. And then hopefully on your calculator you should get x bar equals, so the mean equals 58.875, and on your calculator the standard deviation is 37.35. We're then asked to compare in context. So in context, the estimated mean, the standard deviation, scored in these 80 frames with those in the 2015 final. And the 2015 final were given to us on our data sheet as being the mean and the standard deviation. So looking at this, the final in 2015 has a slightly higher mean. So this tells us that he scored more points in each frame in 2016. And if you look at the standard deviation, it tells us that the standard deviation is larger in the 2015 final, so his scores were more varied at that time. So what we've got is mean was higher in the 2015 final, and then the scored more points each frame is our context bit. And then standard deviation in 2015 final was higher, so this suggests that the scores were less consistent. So you should end up with some fairly positive correlation, a little bit spread out, but very definitely a pattern going up. We're then asked to calculate the correlation coefficient. So what we're going to have to do is, in our calculator, we're going to have to put in this list of all these points. So we've got our hairs on our X column, we've got our links on our Y column, and we want to calculate the regression, and we want X because it's a straight line, and we are generally happier using Y equals mx plus c, so we're going to want ax plus b. So correlation coefficient between the links and the hair, or the hair and the links, is going to be our value of r. So we have r equals 0.8923, and that's for B part 1. Now it tells us that it's proportional to the population size. If it's proportional, then its value of r is going to be exactly the same. So they are just giving you another mark for writing the same thing twice. Then we're asked to calculate the equation of linear regression. If you've got one of these calculators, you've kind of already just done that. You've got your equation of the line at the bottom. So for C part 1, you have y equals, and it says here a, so we want a to 3 significant figures. So 0.376, x plus b, so we want the x, and then we want b, which is 12.7 to 3 significant figures. So explaining context what the gradient means. So we are kind of used to the fact that this tells us for each one we go up in the x, we go up by this much in the y. But here we're talking about thousands, as it tells us on our data sheet, of hairs. So we know that for every additional 1,000 hairs caught, 1,000 hairs caught, we would expect an extra 376 links pelts. So as our hair have gone up by 1,000, our links will have gone up by 0.376 thousand, which is an extra 376. then using your regression equation to estimate the number of links. So we are estimating links and we know how many hairs we've got. So that's 120,000. So our X value for our hairs is going to be 120 because we're looking at this in thousands. So what we can do is, if we move that out of the way, we've got our X is 120, so we can substitute this into our equation, which gives us a value of Y equals 57.82, which equates to an expectation of 57,820 links pelts. Okay, fetal growth. So we can see that we have a mean, we have a standard deviation, and we want below 1300. So for AI, we have mu is equal to 1055. We have sigma equals 140, and we have an X value that is less than 1300. So if we put little x as that and we want below, then we're going to want the probability that big X in context is less than or equal to whatever our little x was, and that is going to be equal to the probability that big Z is less than or equal to little x, take away mu over the standard deviation. So that gives us the probability that Z is less than or equal to, and then if we stick that on a calculator, we get 1.75, and so that gives us 0.9599. Then we want the 10th percentile. So for AII, our mean and our standard deviation are the same. We don't know X, but we do know the percentage. So when the percentage is going to be equal to 0.1, then Z is going to be equal to minus 1.28. So we know that minus 1.28 is going to equal X minus mu over 140. So X is going to equal 875.8. So we've got the probability that big X is less than or equal to 875.8 is going to be 0.1. Okay, so part B. Part B is sneaky. I kind of like this because it's one of the questions that we had in the pre-release. And actually all you've got to know is that the mean is in the middle on this curve. So the mean is going to be halfway between the 10%, which is at 3004, and the 90%, which is 4234. Because it's going to be halfway, if we add those together and divide by 2, we can find out what the middle is, and that should be 3619 grams. So, for part 2, we are asked to calculate the standard deviation. So we need to know sigma. What we can do is we know that the probability that x is less than or equal to the 90th percentile is going to be equal to 0.9. So if that's the case, 0.9 gives you a z value of 1.28. So we can use our z equation and go z equals x minus the mean, which we found in the previous question, and then we can divide that by the standard deviation. So to rearrange to find your standard deviation, we've got sigma equals 4234 take 3619 all over 1.28. So sigma equals 480.5.